and gentlemen, please welcome Executive Vice President, Hardware Department, Oracle, John Fowler.
Obviously, cloud is a very, very big topic this week, and Oracle plays an enormous presence in enabling cloud computing, from the application software, infrastructure technology, enabling everyone from SaaS to platform to infrastructure as a service provider. So cloud is a relatively new topic. It's become regenerated of late, and obviously Oracle's customers across all industries, we have thousands upon thousands of customers that are implementing cloud computing using Oracle products, whether they're themselves delivering software as a service or developing private clouds internally to deploy their internal services, and many other facets all in between along the entire spectrum of capability. Today, I want to talk about our cloud infrastructure and how Oracle is investing in developing the technologies to enable cloud infrastructure across all the main cloud types. We start with, and as the only vendor building from applications through the hardware, we start with the core principles that we're going to use our engineering capability across all of those different disciplines to build the best possible cloud products. That's not just because we actually have those technologies in-house. It's because deploying cloud infrastructure is enormously complex. It's really not just about doing a virtual machine to run any native application. It's about being able to manage and secure and properly run your entirety of mission-critical infrastructure. So we start with investing in core technologies of server and storage to allow people to build products, build infrastructure using the products in a traditional way if they so wish, to add to and augment their existing infrastructure. With these, we're driven to build the best possible performance, security, and availability. Our second principle is we're using our knowledge and capability of developing the software stack to then drive intrinsic changes in that hardware, whereas how we do compression, how we do security, what can we do around performance, what can we do about testing and other reliability enhancements to create the best possible infrastructure, not just to run a generic application, but to run Oracle's applications. And we now have, 2 years into the Sun Oracle acquisition, have now delivered a suite of products that actually have that intellectual property embedded to go run Oracle better when deployed in a cloud. And then finally, engineered systems. For the superheroes and for the rest of us, we've combined servers, storage, and networking. But this is not an engineering exercise to go in and just take what I have in the warehouse and ship it to you in a bigger box with a bigger tag. This is about taking the software and hardware and actually engineering a different result than we've had for decades now, and to deliver the performance and the capability you need. This is a sea change in how people are looking at computing. And you're going to see, obviously, over the last couple of days, you had Larry, and Andy Mendelson, and Lon Loiza, and many other speakers talking about this. We're talking about this because we're so excited. For decades now, the way people build infrastructure for the cloud, for their applications, and then try to do it for the cloud, is all the same way. If you go back several decades, you take an application, you build a siloed environment. You got the storage and the servers and everything dedicated, you build it up, and then you can't change it for 10 years. The cloud is a completely different animal. But what people have been doing is applying that same process to building their infrastructure for the cloud, which is I'm going to go pick from a whole suite of different vendors and go build some infrastructure, and somehow it's going to be able to handle a whole range of applications and do a great job for me. So we think there's a different way of doing it. And that's what we've been engineering over the past few years, and which is why you see so many excited Oracle speakers, including myself and Larry and others, is because we know that by engineering the storage and the network and the servers together with the software, we can give step changes in different kinds of results as opposed to 10 and 20% changes, different capability. We also know that we're going to be able to support it better and that you can run it better because you actually have a holistic approach to how these systems can be deployed and then managed. And now with thousands of installations worldwide, Diane brought up a customer just in the last session, we now have thousands of installations worldwide. The theories of engineering are now proven out in practice. You know, what do we see routinely in customer sites? Very, very rapid deployments. You know, it's a huge cost saver to be able, instead of integrating all the systems yourselves, be able to actually have a starting point of a great system that's already tuned and started for you. Tremendous performance. So I was actually at a cocktail reception earlier this week, and I had a customer tell me that their database application runs 1,000 times faster on Exadata. Now, he had a drink in his hand, but he didn't seem that inebriated. But the data source wasn't valid enough for me to go back and change my slide. So I didn't want to say up to 1,000 times database acceleration. But I'll give the guy some credit. He was very excited too. But you know, the idea is what we've done from an engineering standpoint is actually using an architecturally different approach. And we do see startling results from customers on different workloads and what they can actually get. And then finally, on availability, what we're doing here is, since I am engineering the hardware, all of it, and we are testing it together with technologies like WebLogic and the database, I have what you have. It's very important to understand, when you call in and you build your own disparate infrastructure of a whole range of different technologies and the fiber channel SAN and everything else, I don't have exactly that. But with our engineered systems, I have that. And therefore, we use proactive service response, including remote telemetry, to respond immediately to things. We have service offer where we actually patch the entire thing. I mean, the entire thing. From the database all the way to the firmware and the controllers, we test that, and you're in complete coherence with what we know works for an application workload. And we think this is absolutely transformative for cloud computing, as do thousands of customers. If you look at deployment, and I'm talking here about a complex deployment, I'm not talking about running some jelly bean app in a small environment, but if you're talking about a real mission critical deployment environment, in a typical scenario today, you have to acquire network components, storage components, server components, operating system technologies, virtualization technologies, who knows what, and you're actually putting together an infrastructure to go run things. And you're making many decisions along the way about the workload and how I want to manage it and what's my favorite vendor and all kinds of things. And so a typical large-scale deployment that includes hardware procurement can take months to do a real production go live. And I'm involved in many of these. It's a tried and true thing that people do, and they're very used to it. And what we do is we measure deployment time to production for engineered systems. And it literally is, by comparison, weeks. And you can have shorter examples, but I'm trying to give you a realistic example of a large-scale mission-critical application from start to finish. And so this is an incredible savings in cost, an incredible savings in time, and then also you get to do your business more quickly. When it comes to system support, when we originally started this out, one of Larry's visions here was, if we're actually building and testing all the hardware, we can deliver a better support model. And we're now doing that with platinum level services, which is available to and included with Premier support for all the customers using engineered systems. And in this, using remote telemetry, since I know exactly what you have, we can proactively notify. Within 5 minutes, we're actually working on a problem, whether it's software or hardware. And also, Oracle itself will manage and apply quarterly patch updates, which is an enormous benefit to customers because we're applying those patch updates in a completely synchronized way across the entirety of the system stack, from the firmware of the hardware all the way through the database. So customers are now out of sync with what we believe is the best possible way to run the platform, not just from our own testing, but from the feedback loop we have from thousands of customers in production, where we know what does and doesn't work, and we make sure you're in synchronization with that, and you're in effectively the swim lane of what's the right configuration for these systems across an enormous stack. And understand, as that includes the database, it includes a very substantial body of software, including the operating system virtualization and other layers. And this, I think, is just the future of how we're going to be doing support of hardware in the future, which is not having you staff and understand the coherence function between all the different application spaces, but rather use the fact that we have, in fact, engineered it together, and that we have live telemetry with all the other customers, and therefore knows what does and doesn't work to keep the engineering teams honest, and then you draft behind all of that. Obviously, with thousands of customers, we have a huge number of customer references, many different case studies. The technology itself was so breakthrough, to be honest, we weren't exactly sure, some of the places it would happen and not happen. But we see numerous examples using all of the situations that I showed you. Getting to speed of deployment, having enormous performance improvements for batch and online reporting, and then savings through the technologies that we're able to apply, like compression, and so on. So what's behind some of this? And I know I occasionally get questions, hey, you guys are using some standard components. How is this actually different than what I could do myself? This is systems level thinking. And so if you look at Oracle, we're a systems company, but with Sun, obviously, what you think about of a system is operating systems and servers. Oracle is actually a systems company at a different level. We think about that and the database and middleware and applications. To us, that's what a system is. How can we go innovate at the systems level across that entire capability? And so what we've done in Exadata over time is we have invested in actually moving system-level capability, which is presently in the database, actually into the storage, and using a distributed query architecture to access it. And because we can actually use any part of the system to go build that and design and change what we want, we're actually able to do that. We use industry standard technologies in there as part of how we build it, but the overall systems architecture, if you think about it, is a system that includes the higher level database and the higher level middleware, as opposed to where people used to draw the line in the system, which is you stopped at the operating system or the storage unit. For us, it's just a much bigger playground, and in that we're able to create a system that behaves and acts differently, because it's not a brute force approach only to the individual components. It's an integrated approach to how you run those particular applications. Earlier this week, we announced Exadata X3, and one of the things I want you to think about in engineered systems is, you've been thinking about them as point products. We look at these as platforms. So we're constantly looking at how do we update the software, add feature capabilities, incorporate new hardware components, while at the same time maintaining the architectural coherence of Database 11 so that your applications simply do not change. And across a multi-year transformation now, we've gone from what started really as a pure warehouse read workload type system to include the ability to do OLTP and then scale up. We've added Unix and virtualization to create a more general purpose system to incorporate applications. And then this year, we've added a massive upgrade to the storage capability with a significant upgrade in both the storage cell controllers themselves, as well as the software and technical capability on them. And what